scenario.
This would be more than millions of Hiroshima bombs going off all at once.
The ground shook, the skies darkened, and ash clouds raced across continents. Volcanoes from Hawaii to Kamchatka erupted almost simultaneously, leaving scientists stunned. What triggered this sudden fury? Could it be more than just Earth's restless crust? Reports hint at a link to intense solar activity, raising chilling questions about unseen forces connecting the sun and our planet. The world watched, holding its breath as nature's power revealed a terrifying synchrony. The weak Earth wouldn't stay quiet. According to the Global Volcanism Program from the Smithsonian and USGS, dozens of volcanoes remain active during any given period. This has been true for years. In the first week of October 2025, the picture looked similar. Historical records show that the Earth normally hosts about 40 to 50 eruptive systems at any moment. This is what many scientists consider the regular heartbeat of the planet. It expands, it contracts, it releases pressure to stay alive. What made this particular week so gripping was not the number of eruptions, it was the timing. Reports began spreading about scattered flare-ups across multiple continents, happening so close together that even experts paused. It was as if a chain reaction had clicked into motion. Some eruptions were minor, others were larger and more dramatic. A few were still classified as unrest rather than full explosions. Yet the pattern of activity created a sense of unease. The world does not often witness so many dramatic signals in such a short window. Still, scientists reminded everyone that clusters can happen by chance. The Earth is always active. 30 to 60 active volcanic systems around the globe fall well within normal limits. The situation might look frightening, but nature often behaves in ways that appear unusual even when they are entirely ordinary. Many volcanologists repeated that the planet was not breaking its rules. It was simply continuing its endless cycle. Even so, something felt different. Beneath the reports and expert statements, a strange tension hung in the air. People could not shake the feeling that Earth was trying to say something and that this burst of energy was not random at all. Beneath the surface of this seeming normality, a quiet pattern was forming, and it was about to blur the line between ordinary volcanic rhythms and something far more unsettling. The giants that woke up. That uneasy week did not end with scattered tremors. It grew louder as some of Earth's most famous volcanoes stirred at once. Each giant rose from a different corner of the planet with its own history and temperament, yet they all seemed to answer the same silent call. In Hawaii, Kilauea brightened on October 3rd, 2025. This volcano is known for its long and steady personality, but in moments like these it felt almost alive. Its lava lakes swelled and vents crackled as if something deep inside was rising to the surface. Scientists watched closely because whenever Kilauea became restless, it often marked the start of a new phase rather than a routine flare. Far across the Pacific, the frozen lands of Kamchatka erupted with thunder on October 5th, 2025. Bizimiani sent fresh plumes high into the sky. Shevelush rumbled with low, ominous growls, and Karimsky released bursts of ash that drifted far beyond its slopes. This cluster has always been dangerous, but there was something striking about how many flared within the same narrow window. Even veteran researchers felt tension as one peak after another lit up the remote peninsula. The story continued in Southeast Asia. On October 6th, 2025, Canlaon in the Philippines rose from months of uneasy silence and erupted again. Ash clouds drifted over farms and forests, reminding villages long accustomed to its unpredictability how quickly it could shift from quiet to violent. Each eruption felt like an echo in a growing chorus from around the world. These giants came from different worlds beneath the crust. One fed by a deep plume in the middle of the Pacific. Others were shaped by colliding plates under snow-covered mountains. and one was fueled by pressure building beneath a tropical arc. Their landscapes, climates, and histories shared nothing, yet their voices rose together as if caught in the same invisible current, sending a shiver through observers around the globe. When distant volcanoes begin to rise like synchronized giants, the world cannot help but wonder what force is calling them awake at the same time. Electricity beneath the ground. Why do these volcanoes ignite across distant continents at the same time? This idea quietly turned everyone's attention to scientific conversations. It was a theory that sat on the edge of mainstream science. It suggested that the true spark behind these eruptions might not come only from shifting plates or rising magma. It might come from far above the Earth itself. The Sun, despite being millions of kilometers away, constantly sends waves of charged particles toward our planet. Most of the time, they glide past harmlessly or get caught in our magnetic field. But during strong solar activity, these particles can arrive with force and intensity. They disturb the atmosphere. They twist magnetic lines. They create storms of pure electricity in the space above us. Some researchers have wondered whether this invisible energy might reach deeper than we think. A few studies have attempted to measure the link between solar disturbances and Earth's seismic behavior. One study from 2014 used global earthquake records alongside solar wind and magnetospheric data. It found a slight but noticeable influence. The effect was not dramatic, but enough to make scientists curious. It suggested that the Earth's crust might respond in small ways when the solar wind changes its rhythm. Other researchers claimed an even stronger connection. A report cited by some media sources from the Space and Science Research Center claimed that surges of charged solar particles appeared to correlate closely with large earthquakes above magnitude 5.6. Their idea was simple, yet bold. When the Sun sends a wave of energetic protons toward Earth, those particles could disturb the magnetic field. The magnetic field then could stir up electrical currents in the ground, and those currents might add tiny but meaningful pressure to zones already under stress. The possible mechanism behind this theory focuses on how geomagnetic disturbances create what scientists call telluric currents. These are natural electrical currents that flow through rocks and soil. When they intensify, they may interact with quartz-rich formations or other crystalline structures deep underground. In theory, this interaction could slightly alter the stress in fault lines or even influence the pressure inside magma chambers. If the system is already near its breaking point, the added stress might be enough to tip it over the edge. But this idea remains one of science's most debated theories. The US Geological Survey makes it clear that no proven reproducible causal link has been established between solar storms and earthquakes or volcanic eruptions. Many scientists argue that the correlations seen in some studies disappear when examined in different regions or longer time periods. Earthquakes often strike when the sun is quiet. Volcanoes erupt with no hint of geomagnetic disturbance. The connection may simply be coincidence rather than cause. There is also the question of depth. How does energy from the ionosphere reach magma chambers buried far beneath the surface? There is no confirmed pathway. Much of the idea relies on models rather than real-world measurements. If energy from space could truly reach beneath the crust, then the next solar storm might not only light up the sky, it might stir the hidden forces that hold the planet together. The solar engine reawakens. Scientists observed that the sun had begun to show signs of renewed activity. Its surface rippled with magnetic knots, twisting and tightening like coiled ropes. And from those tangled regions, eruptions of unimaginable power were preparing to break free. Solar flares and coronal mass ejections are born from the sun's chaotic magnetic interactions. These eruptions release bursts of radiation and clouds of charged plasma that race across space at incredible speeds. Even when the sun moves through a quieter cycle measured by fewer sunspots, it can still unleash storms strong enough to shake satellites, disrupt power grids, and rewrite the patterns of Earth's upper atmosphere. Researchers studying past events found something troubling. A comparison of the July 2012 and July 2017 eruptions revealed that successive blasts can interact with one another. When multiple eruptions collide or overlap, their magnetic structures weave together into storms far more powerful than any single flare could create on its own. These hybrid storms can grow unexpectedly, becoming almost invisible threats racing toward Earth until it is too late to predict their strength. By late 2025, reports began circulating about a surge in X-class solar flares. These were the kind of flares that make scientists stop what they are doing and check their instruments twice. Some media outlets suggested that the spike in solar activity might connect to rising volcanic and seismic concerns back on Earth. The idea spread quickly, even though it came from speculative sources rather than well-established research. Still, the timing left many wondering whether the sun was once again pushing on the magnetic shield that surrounds our planet. Despite the excitement, much remains unknown. The sun is one of the most complex magnetic systems in the solar system. Its surface changes constantly. Fields twist, break, reconnect, and crack open without clear warning. Even with modern technology, no one can predict with certainty when an active region will erupt or how strong the blast will be. The sun keeps its own secrets and releases them on its own schedule. And even when powerful storms reach Earth, their influence deep beneath the surface is still unproven. Could electromagnetic surges or enhanced telluric currents slip through the crust and affect magma chambers or fault lines? No confirmed evidence exists. The idea belongs to the borderland between theory and possibility. It is a setting ripe for dramatic storytelling, but it is not yet a scientific rule. Beyond the red glow of solar flares, something darker was gathering. As its hidden storms pulsed outward, the Earth braced itself for an answer that would come in quakes and rising fire. A planet under pressure. A 2022 analysis traced more than 2 centuries of volcanic activity and compared those records to the shifting background magnetic field of the Sun. The result stunned even its authors. The data showed a correlation close to 0.84, suggesting that peaks in volcanic eruptions often occurred during solar cycles dominated by a southern magnetic polarity. If correct, this meant that Earth's most violent geological episodes might rise and fall in harmony with the Sun's silent magnetic shifts. This idea carried a strange weight. Earth's deep interior is driven by forces older than any living memory. Mantle convection carries heat outward. Plates grind against one another. Magma rises when pressure becomes too great. Everything we know about geology points inward toward forces locked beneath continents and oceans. Yet the study hinted at something different, the possibility that Earth's own timing may carry an imprint from the star that gives us life. But even with its striking numbers, the theory remained precarious. Correlation is only a suggestion, not a verdict. The researchers themselves admitted that the alignment between eruptions and magnetic polarity was far from perfect. Many volcanic peaks did not match the predicted solar pattern. Some eruptions occurred during phases when the Sun's magnetic orientation should have had no influence at all. The idea of a cosmic rhythm was intriguing but incomplete. Earth's volcanic system is a tangled web of physical processes. Tectonic plates grind slowly but relentlessly. Mantle plumes rise from great depths and reshape the crust over millions of years. Magma chambers expand and contract like hidden lungs. Local stress fields build up until a fault gives way or a vent opens. These internal movements dominate the planet's geology. It is unlikely that solar magnetism by itself could control global eruptions when so many powerful forces operate from below. Even the proposed mechanisms remain theories without grounding in direct evidence. Some scientists suggest that solar cycles could generate subtle electrical currents in Earth's crust. Others point to the piezoelectric properties of quartz-rich rocks, which might react to electromagnetic fluctuations. The possibility of a faint external influence hangs in the air like an unfinished melody. And if that hidden melody truly exists, then far beneath sunlight and storms lies a cosmic metronome, quietly setting the pace for disasters yet to come, the possibility no one wants to consider. For centuries, Earth has carried the scars of eruptions so powerful they reshaped climate, devastated regions, and left fingerprints in ice cores and ancient chronicles. These were not ordinary volcanic events. These were global turning points, moments when the planet reminded humanity of its true scale. One of the most dramatic examples is the Somalis eruption of 1257 in Indonesia. This explosion reached a magnitude that few eruptions in recorded history can match. It blasted immense volumes of ash and gas high into the stratosphere, building a veil that circled the planet and dimmed sunlight for months. Temperatures dropped, harvests collapsed in different regions. The climate trembled for years under the weight of what one volcano had done in a single moment. Another mystery lies in the mid-15th century. Ice cores reveal sharp sulfate spikes in 1452 and 1453, pointing to one or more massive eruptions whose exact source remains uncertain. These events likely intensified the cooling that shaped the Little Ice Age. Their force was strong enough to leave long shadows across continents, influencing weather, agriculture, and the societies that depended on both. Even without knowing their precise origins, scientists agree that they were among the most significant volcanic events of the last 1,000 years. What these examples reveal is unsettling. Earth does not need dozens of active volcanoes to create global chaos. It only needs one eruption of the right size at the right moment in the wrong place. And history shows that such eruptions are not ancient relics. They are part of Earth's normal behavior, capable of returning at any time. This is where some researchers introduce a speculative yet provocative possibility. If the long-term correlations between solar magnetic cycles and eruption frequencies hold even partly true, then cosmic rhythms might occasionally align with Earth's internal pressures. Imagine a stressed magma chamber waiting for a final push, a small shift in the crust, a subtle change in electromagnetic currents. A trigger so slight it would normally pass unnoticed, but under the right conditions, it might reduce the last barrier holding the system back. Yet, even fringe ideas can stir discomfort when history reminds us that the planet has already unleashed events that few imagined possible. And if the smallest chance exists that cosmic and geological rhythms can collide, then the question is not only scientific, but existential. If the odds are tiny, but not zero, then the countdown may already be moving, quietly advancing toward a moment the world is not prepared to face. The unseen alignment approaching 2026. As scientists monitored the sun's rising activity and geologists tracked the restless tremors beneath the crust, another idea surfaced from the edges of scientific discussion. It came not from major research institutions, but from independent analysts and small media outlets that follow solar weather. According to them, the year ahead carried an unusual combination of astronomical and solar conditions that could create a perfect stage for heightened planetary stress. They pointed to the planetary alignments predicted for 2026. These alignments, they claimed, might amplify electromagnetic disturbances already stirred by an active solar cycle. In this view, the alignment of several planets could strengthen the flow of charged particles, shaping the way solar wind interacts with Earth's magnetic field. If this interaction became intense enough, they argued it could send deep electromagnetic ripples through the planet itself. These authors suggested that surges in proton flux, bursts of solar wind, and strong geomagnetic storms could arrive during a moment when Earth's crust was already under stress. In such a scenario, a volcano with a swelling magma chamber or a fault line nearing its breaking point might be pushed just far enough to release its stored energy. A small nudge in the right moment could transform into something far larger. But this dramatic chain of events stands on uncertain ground. The idea that planetary alignments influence Earth's geology has not been confirmed by rigorous research. The gravitational pull of other planets, even during perfect alignment, is tiny compared to the immense forces generated by Earth's own moving plates. And while electromagnetic interactions between the Sun and Earth are real, their ability to affect deep crustal structures remains unproven. Many of the studies attempting to link solar activity to earthquakes or eruptions face tough scrutiny. When statisticians remove random noise or account for unrelated variables, the once strong connections often fade. What remains are patterns that may be coincidence rather than cause. This is why most geophysicists treat such claims with caution. Leading authorities repeat a simple truth: earthquakes and volcanic eruptions are powered by internal dynamics that have shaped the planet for billions of years. Solar flares may light up the sky, geomagnetic storms may disrupt satellites, but the grinding of tectonic plates, the rise of magma, and the buildup of fault pressure come from within. Even so, the idea of a cosmic trigger continues to attract attention because it taps into a deeper fear. It suggests that Earth is not only unpredictable, but also connected to events far beyond human reach. And when people look at the growing solar cycle, the clusters of eruptions, the whispers of alignments, they wonder whether these coincidences are as harmless as they seem. What do you think? Could cosmic forces really stir Earth's hidden fury, or is it just a coincidence? Share your thoughts in the comments below.